Hello friends, welcome to Secret of Electronics. In this video, we are going to explore how we can use the multi-core functionality of the Raspberry Pi Pico W board using Micropython. To make things simple and interesting, we will connect an MQ5 gas sensor, a 16x2 I2C LCD, and a LED. One core will handle blinking the LED, while the other core will continuously read the sensor values and display them on the LCD. This circuit shows the connection of a Raspberry Pi Pico W board with a 16x2 I2C LCD, a MQ5 gas sensor, and a LED. The Pico W board is powered by a plus 5 volt input, and LED with a 220 ohm current limiting resistor is connected to GPIO pin 15 of the Raspberry Pi Pico W board to act as a simple status or output indicator. The I2C based 16x2 LCD is connected to the Pico W board using GPIO 0 SDA and GPIO 1 SCL for communication, while the LCD is powered by the plus 5 volt supply. With its ground connected to GND, the MQ5 gas sensor module is powered by the regulated 3.3 volt output of the Raspberry Pi Pico W board, and its analog output is connected to the GPIO pin 26 of the Raspberry Pi Pico W board, allowing the Raspberry Pi Pico W board to read gas concentration levels as an analog value. The digital output of the MQ5 is not used in this circuit. Now let's go through the code step by step. First, we import the required modules. Pin lets us control GPIO pins. ADC is for analog to digital conversion. I2C is for LCD communication. UTime gives us delays. Underscore thread allows us to use the second core of the Pico W board. And finally, I2C LCD is the driver for our LCD. Next, we set up the hardware. Here the LED is connected to GPIO pin 15 and the MQ sensor's analog output is connected to GPIO pin 26, which is an ADC pin. Now we initialize the I2C bus and the LCD. This tells the Pico W board that SDA is on GPIO pin 0 and SCL is on GPIO 1, and the LCD is a 16x2 display at address 0x27. If your LCD has a different address, you can change it here. Let's move on to the fun part, multi-core task. Core 1 task, LED blinking. This function will run on core 1. It simply toggles the LED every 0.5 seconds, creating a blinking effect. Core 0 task, MQ sensor reading plus LCD display. This function runs on core 0. First, it reads the analog value from the MQ sensor. Since the Pico gives a 16-bit value 0 to 65,535, we convert it to voltage using the formula. Then we clear the LCD, print the raw sensor value on the first line, and print the converted voltage on the second line. Finally, it waits for 1 second before reading again. Finally, we start our multi-core execution. Here the LED blinking function is launched on core 1, and at the same time the main core keeps running the MQ sensor and LCD code. So in summary, core 1 handles the LED blinking, core 0 continuously reads gas sensor values and updates the LCD. This way, both tasks run simultaneously without disturbing each other, showing the real power of multi-core programming on the Raspberry Pi Pico W board. Now connect the Raspberry Pi Pico W board to your PC or laptop using a USB cable. After connecting, open the Thony IDE. Under the shell, you will see the Micropython version, which means our Raspberry Pi Pico W board is successfully connected to the PC or laptop. Next, copy all 3 code files one by one, which you can download from the link given in the description. After copying, paste the codes one by one into the Thony IDE and save them on the Raspberry Pi Pico W board with their respective file names. Now disconnect the Raspberry Pi Pico W board from your PC or laptop. After disconnecting, connect all the components together according to the main circuit diagram that we discussed at the beginning of this tutorial. Once everything is connected, power the circuit with a 5 volt DC supply. You will now see the LED blinking with the specified delay, and at the same time, the MQ5 gas sensor values will be displayed on the 16 by 2 LCD.